Now this is gravity according to Rucko.com. So this is an example. Now I'm going to start it over. As you can see, start it over. You have random little pockets of energy. See? Random. They start at random. Okay. Now watch them collapse. Now all those little masses collapse into each other and they can move through each other, away from each other in all different ways. Now if you watch them for a while, you notice they start making elliptical orbits and going round and round, and just like our planet would work, so this would be an atom. You see how they go round and round? So if you release a random amount of these particles light years away from each other or wherever, they will start heading towards each other, but whenever they reach, they will not really crash into each other. They will just keep oscillating. So this is what you could call an inertial system. It could be a proton, it could be a neutron, it could be a black hole. It's the same thing. So we could not sense those that are inside. We can only sense them when they pop out of the shell. So let's start again. They collapse, settling down, all that debris is going around and round. These things more or less are going near to the speed of light. When they reach the speed of light, they cannot influence each other. It's like they can't send messages to each other. They don't know about each other. So the force is just to attract them until they reach the speed of light. And in that little area, only when they pop out we'll get mass. When they are inside we don't get any mass. Now these are just charges. It's based on an electron. An electron, well, my electron has a negative and a positive side, and you can't separate them. So an electron to me has a north and a south pole. So when they reach at the surface like the bubble, their force will be zero. It's like if you are pushing a cart and your cart start running faster than you. So you can't apply any force to the cart because the cart will run away and leave you. So likewise, these electrons are being pulled together, but when they reach the speed of light, there is no way for each one to know about the other. So there is no more pull on them. So the force becomes zero at the end and at the beginning. So when they are far away at infinity coming into each other, the force would be near to zero. And when they reach in that they are doing the speed of light, their force would be also zero. So we are traveling at the speed of light. Even if we are going nowhere, we are traveling at the speed of light. And here we go again. See, they form an inertial system. So a huge atom could be thousands and thousands of these little guys here, these little pockets of energy, freely moving around, but getting locked away. When they reach the speed of light, they can no longer communicate. It's like if you start moving at the speed of light, your cell phone wouldn't work, because the light wouldn't be able to reach your other party. Not only that, the frequency would change. Okay, now the previous demonstration had only 66 particles and this have 666. So the processor doesn't have the power to process it as fast that you can see everything, but this would show you what would happen. Here we go again. All these are just random. and they collapse according to how close they are together. And if you watch this for quite a while, you will see they come down to near to some steady thing that would look like an atom. Of course, with all the calculations on the screen, it won't be exact, because these things are microscopic. 1 pixel on your television screen would be much larger than any of these particles. So the swarm of them, you notice, they form an inertial system. Not much is escaping. Now and then you will see one of them escaping. So inside here, everything reaches the speed of light, while outside here they pop in and out. And these pop in and out, these are the mass of the object. Most of this is hidden. That is why we don't see most of the mass of the universe. But it's still there. No, because this computer is too slow. Not only that, I guess you'd need a supercomputer to be able to process enough of these to make a real atom, because it's a lot more than 666 of them in an atom. But you can still see some little circles going there. Just let it stay. Yeah, these are the mayflies or the mini flies, and each of these is just one little packet of energy, and all of them are the exact same. If you could get close to it and put a magnet against it, you would find that it spins around and attract the magnet. Okay, so this is the best atom I can give you right now until I get a supercomputer. Now let me show you how these little energies work. Okay, now here are 2 ordinary magnets. Now you will notice if I put one here, the other one, if I hold it, it pushes it away, right? But if I should just throw them down together, they spin around and attract each other. That is why you notice gravity always attracts, because we can't see the spin. Now, only God could set them in a way where they wouldn't attract and they would just spin around. So when the universe was created randomly, there was an original spin, so that they will always attract. Nobody could know that these repel each other. They will always attract each other. See? Now you could hold them into a way to repel them. Okay, now we know that great computer programmers can make anything come on your screen. I am not a great programmer. This is just the one equation. This is the radius, the x velocity, and the speed of light. Now each particle has a x, a y, and a z coordinate. Of course, we are only looking at the x and y because we can't see the third one on this flat screen. So the program simply calls this every time, one for the x, one for the y, one for the z, and it adds the velocities, and that is the heart of the program. There is no trick to it. It computes the distance by simple Pythagoras of the x, y, and z distance between each particle. Now if you go to Rucko.com, you will see the simple equation that governs the movement of all particles. So we use this equation, which is the simple relativistic equation of charge. And that is what gravity is. Gravity is charge.